Okay, next video will be solving, but I had to redeem myself. I knew there was another set of factors for 36. Duh, you guys were all thinking it. 6 and 6, right? So I get a 30 and a 6. That'll completely give me a negative 24. My 30 has to be negative. My 6 has to be positive. And then there's my 3 factors. 3x times 5x squared plus 6 times 1x squared minus 6. All right, solving. Last video. Hopefully you're getting through your lessons. So solving means to find the zeros, and they are otherwise known as the x-intercepts. This goes to the whole graphing business. Once we know end behavior and we can find some zeros, then we can get a pretty good idea of what that graph looks like. This should say equals 0. When you solve, that's what everybody loves to say algebra is about, solving. Solving is very specific. Solving is finding the x values that make this equal to 0. So I'm going to look for a common factor. And then if this times this equals 0, this is the old rule. If I tell you that I'm multiplying a times b and getting 0, one of those have to be 0, right? So either x squared has to be 0 or x minus 5 has to be 0. And in this case, x would be 0. In this case, x would be 5. That is why the x-intercept is opposite of the sign here. All right, 4x to the 4th minus 40x squared minus 44. Lots of 4s. Let's take one of those out. And then here's that quadratic form, but here's the quartic, but it's a quadratic form. So I'm going to unfoil. I need two numbers that multiply to be negative 11 and add to be 10. So that'd be a plus 11 minus a 1. Then you got to be careful because check this one out. X squared plus 11, and this becomes an x plus 1 times an x minus 1. That's a difference of perfect squares. And then this guy can never be 0. So 4 can never be 0, but don't forget it's still a factor. X squared plus 11 equal to 0 means x squared equals negative 11. That's a non-real solution because I can never square something and get a negative. So if x plus 1 equals 0, then x must be negative 1. And if x minus 1 equals 0, then x must be positive 1. So this graph is a positive leading coefficient. It's an even. So its end behavior is up, and it crosses at negative 1 and positive 1. So I don't know. It might take a little turn in here. I have no idea. But at least I know it's up and crosses at negative 1 and positive 1. What's this? It's not equal to 0. Well, make it equal to 0. Let's subtract 50x from each side. So now I have 18x cubed minus 50x equals 0. Set it equal to 0. What do 18 and 50 have in common? 2, anyway, x. And then I get a 9x squared minus a 25. And you should recognize these beautiful perfect squares. So that's a 3x minus 5 times a 3x plus 5. And then if 2x equals 0, x equals 0. Do the math here, people. 3x minus 5 equals 0. Add 5. 3x equals 5. I'm running out of space. X equals 5 over 3. Right? Divide both sides by 3. 3x plus 5 equals 0. Subtract 5. 3x equals negative 5. Divide by 3. X equals negative 5/3. So what are my x-intercepts? X equals 0. X equals positive 5/3. X equals negative 5/3. So this graph, positive, odd. So it goes down to the left, up to the right, and it crosses at negative 5/3 at 0 and at positive 5/3. So it, does something like that. Putting it together, starting to graph. I think I have two more for you, if you're not sick of it yet. Another quadratic form. factors of 60 that combine to be 4, except that I'm talking about a quartic, so it's squared and squared. 6 and 10. Easy ones, thank goodness. And the 10 has to be negative, and the 6 has to be positive. What happens here? Can x squared plus 6 be equal to 0? Then x squared will equal negative 6. Non-real. We talk about imaginary, right? X squared minus 10 equals 0. X squared equals 10. So x equals plus or minus the square root of 10. That crosses at positive square root of 10, negative square root of 10. So again, this is a quartic. What's the square root of 10? It's going to be a little more than 3, right? Because the square root of 9 is 3. So up and up, and somewhere here at negative root 10, and somewhere here at positive root 10, it crosses. There might be a little squiggle in here, I don't know. Oh, and factor by, as soon as you see 4, you should think factor by grouping. Here's a group, here's a group. All I can do out of here is get in x squared, so x plus 6. Going to factor out that negative 4, so I get the nice x plus 6. So however you want to look at it, I like to think that I'm pulling out the common factor, and what I'm left with is the x squared minus 4, and then x plus 6, and this beautiful perfect difference of perfect squares, and I'm going to shortcut. X will have to be negative 6 to make that factor 0. X will have to be positive 2 to make that factor 0. X will have to be negative 2 to make that factor 0. Here's my positive cubic. Down to the left, up to the right, and negative 6, negative 2, positive 2. Something like that. Who knows? Close enough, though. Good enough for us. And also these zeros become important in calculus and how you find these maxes and mins. You can find those in calculus. The factoring and knowing the end behavior, finding the zeros, all that helps us get a pretty good idea of what we're looking at. All right, that is a good bulk of that chapter. Hopefully it all goes well for you.